Welcome everyone. Welcome back to Devoxx Belgium, the live Q&As we're doing here this week. We have Gavin Bierman here today. Gavin, for those people who don't already know you, why don't you introduce yourselves?
Hi, I'm Gavin Bierman. I work in the Java platform group at Oracle. And I guess the things I'm most involved with is working on Project Amber, which is mainly the language features, new language features for Java. And I also do a lot of work on the specification.
Okay. You have a talk here called Java Language Futures, which is a very broad one. That could be everything and anything.
Yeah.
So what is it about though? So what are some of the topics you're touching on?
Yeah. So what I'm trying to do is take a sort of broad view over what we're up to in Project Amber. So all the great things we're doing there. Kind of show, I want to talk about what it's all about, why we're doing it, some things that people think what we're about that aren't really what we're about. And then I want to kind of look at some of the things we've done in the past, in the recent past, some new features, and why we added them. So not just what they are, because you can read the JEPs about those, although I will explain them, but also, why did we pick those? And in particular, this is about features that combine together to give you this, what we call data-oriented programming style, so a new way of writing Java applications that we're actually super excited about. We've been interesting here talking with people who've been rewriting their applications to use this style. So that's very exciting. So we think it's a very cool thing. And then towards the end of the talk, I kind of want to look at what's coming in the pipeline. So features that, have actually got JEP numbers that are really going to come out sometime soon, but actually also features that are, they're more than just in my notebook, but not quite there yet. But kind of to give people a sense of where we're going with this in the future.
Yeah, I think specifically if you want to explain that this belongs together, it really helps to not only see like the point, but the arrow in time. It's like, okay, so this is where this is leading, and this is how.
Yeah, exactly. So I think it was a big shift in the way Java is delivered with this change to 6 monthly releases, and there was a lot of apprehension when that came in. But we've really realized that we should grab this with both hands. So we've realized that it's a great way for us to develop new language features. So we take even ones that we think have a big, broad picture with lots of features that combine together. We've realized actually the best way to do it is to take small features and individually evolve them, and it slowly comes together. Now, the great thing of doing that is in particular using the preview feature, it means that we can introduce a new extension. People see where we're going. We have roadmap papers and stuff, but we can say, hey, here's the first one. Try it out. Tell us how it goes. And then over time, then if we get good feedback, that finalizes, becomes a feature, and then the next extension to it comes. And then over time, we've evolved a great whole suite of features that come together. But we did it in a very slow way. If you take the long view, from our view, it's like we're continually shipping. It's like chaos all the time. So we're always shipping new things, multiple new things all the time. But it also means that we can make fine corrections. Because the thing that we're very aware of is, the great thing of Java is it's still going after such a long time, right? In computing terms, this is a overwhelming amount of time that it's been available. So when we finalize a feature, it's really there for all time. So we really want to make sure we've hit it right in the bullseye. And we've had pretty good record. We've been very close from the start. But occasionally people say, it would be much better if that thing did it slightly differently. So we can make very fine adjustments to correct something. So it enables our community to kind of be involved, to try things out. We get feedback. We have the experts group talking about things. But it means over time, we can actually really ship what turns out to be big changes to the language, but in small bits. Yeah,
I think the poster child for that is, I think also there are a few things that have been developed that way, right? Like the foreign function memory API and also virtual threads, but they are not really impactful on the language level, right? There are other areas. And I think on the language level, you can really see this piecemeal addition of features is pattern matching.
Exactly.
Where we saw like all this is like the first real big chunky feature that has been delivered in these slices. But even just pattern matching is not the whole story, right? You mentioned data-oriented programming, so can you maybe talk a little bit about how that fits in there, and how data-oriented programming maybe is more than just pattern matching? What else is involved in that?
Yeah, so it's a number of features that come together. So the real idea behind data-oriented programming is just the fact that for a number of situations, not all, but many, the thing that you want to pass around in your application is just pure data. It's not a big business object with complicated boundaries that you observe in that where all the instances are long-lived and so on. If you're doing that sort of stuff, I tell you, the best language in the world is Java. We already shipped it. But if you want to ship around pure data, where the data is kind of immutable, but still you want all the great benefits from Java, like strong typing and you want consistency from constructors and stuff like that. We wanted to add features to make that better. So, of course, in Java you could code everything up, but it was quite difficult to get data that looked like that into place. So what we did, we added a new sort of class, the record class. So it's a very succinct way to declare shallow, immutable carrier class objects. So you don't write very much, but you get this sort of beautiful construct out of the back end. We gave you a way to seal up your hierarchies. Before, Java had this weird thing where, I don't want to say weird, had a feature which was when you declared a class, either nobody could inherit from you, or everyone could inherit from you.
I mean, with classes, you could play tricks with like protected and private constructors, but interfaces, I think, is a simpler example.
That's not. You shouldn't have to do that to say what you want.
And interfaces you can, right? It's either package visible or public, and then everybody.
Exactly. So we gave you this feature. So we said, you know what? In a class or interface declaration, you can actually spell out all the implementations, all your subtypes. Now, together, what that gives you is a very simple way for you to declare essentially abstract data types. So where you have a foo and it's either a bar or a pop. Now you can say that. The bar and the pops are all records. So now you have a very simple way to describe the sort of data types that you want to pass around, this pure data. Now, the cool thing is that these records, we gave you advanced pattern matching features to compare your value against a record pattern. And if you matched it, you got the record value would be pulled apart and you would have in your hand all the components of the record in like one tiny little expression. So it's very nice. And you could nest all of those. So you could query and say, oh, my abstract data type, which was this sort of complicated hierarchy, I would say, are you one of these, containing one of those, containing one of those, containing one of those? If you are, I want the color thing out of you. And that's quite a complicated query. Especially if you're worrying about null pointer exceptions as well, and you've got lots of instances of and casts, and maybe you mess them up. And now you just have a pattern that just says, find me the guy that matches that. So all of those things together give you this way to re-architect your code. So this is the data-oriented programming way. Now in the future, what we're wondering about is, can we offer some of those goodies to some of the other features of the language?
So we've seen that today in Angela's talk, where you previewed a little bit of deconstructors for classes. Before we get there, there's a question from the audience, I think, but oh, David, my chat doesn't show it. Do you want to give me your phone? Thank you.
Okay. Technology.
The new Future API, the API of Future, I think, which leverages sealed classes, looks a lot like results as values. Is there any goal to implement this philosophy at a broader scale in Java? I'm wondering, this is, I think, related to your specific example.
Yeah, so I give an example in the talk where I'll be showing how one could rewrite the future class or the future interface to be more data-oriented. I think that I should probably come up with a better example because this is supposed to be an example of what one could do. That I wanted to do this sort of example where if you kind of take a slightly sideways view, you can see something that looks just like a return values and exceptions can all just be seen as data coming through. So we're certainly not committing to rewriting the future interface. I think
I would say we can probably go one step further and commit to not rewriting it.
I'm pretty sure. Well, I'm always optimistic that I could do anything, but we're probably not going to do that. It's a good question about exactly what we can do with other classes in the Java API. I think one of the things, if we go, it's got a neat segue back to what you were saying before with deconstructors. So deconstructors, for those who don't know, what we're wondering is, so for records, when you give a record declaration, you've given in the header all the components and what their types are. So when you write a pattern over them, we know automatically what you mean. So when you have a point in XY, then if you have a pattern, point var A, var B, we know exactly what that means and we can give the semantics of pattern matching. But what about classes, right? Arbitrary classes, what can you do? Well, clearly we cannot know what you meant if you had some class foo and you wanted to write some pattern.
So you're quickly, to catch up the audience, I think the critical difference here is that a record promises that the internal representation matches the external one, whereas the class that has a constructor that takes an X and Y could do arbitrary things to store them,
anything,
and that's not visible to the outside.
Arbitrary class may not have any constructors. Class may have, lots of state, some of which it wants to expose, some of it doesn't want to expose. So you're going to have to tell us, but if we give you a way for you to tell us that, then maybe there would be a way for us to make significant changes to the APIs that we have. So now classes would actually, in the API, they would expose the way that you can pull me apart with pattern matching. And so I think once we get to the end of offering that feature in a real way, then that will be the time for us to actually go back. I realize I'm piling work on my friends in the libraries team, to go back to the libraries and just say, okay, could we actually start changing some of our kind of declarations of classes? Obviously, we're going to have to do that in a backwards compatible way. Always. We never break that. So maybe that would be a way for us to change some of the libraries that we have.
Yeah, so one thing that I realized there, where you really can see this seam between the records and the non-record classes, when I have a live coding talk that I actually give tomorrow as well, but it's called Modern Java in Action. It's already on YouTube from other conferences, you can check it out. And there's also, it takes containers records, and it takes them apart with pattern matching. And then what I get out in one of them is a URL, in another one I get out an exception. But then on the right-hand side of that arrow, I still have to tell the URL to get host and the exception to get message, because those I cannot decompose. Even though it really feels like an exception is just a message and another exception. So that feels like it's really just that thing as well. And the URL arguably also is just the host and the port and several things put together. And really, you can really see the seam between the records and the non-records, because you deconstruct the first half of what you have. And then the internals might not be records anymore, and those are regular classes. And then,
So we'd really like to get to a world where you can do exactly that. You can have the URL, bracket, the pattern for it, brackets, and you can get the thing out, and with exceptions. So we'd really like to bring all of that together, so everyone gets to play the pattern matching game.
I think it's also important to really add to this. This is not, by all means, doesn't mean that all classes will be able to do that, right? Like so many classes, that will be more like service stuff, more like behavioral things.
Absolutely.
For that makes no sense. So I think it's really important. The audience shouldn't think, wait, now everything is just data and gets deconstructed. No, there's absolutely no need to add that to all the classes, just where it makes sense. I have one question that is maybe not on our radar. So maybe if that doesn't work well, the question, just let me know. But I find this interesting. What are your thoughts about effectively final variables in the for loop header?
Okay. So there is a discussion right now. If you go onto the bugs database, there is a discussion and a proposal about which is currently going through discussions. So it's not even at the JEP stage. But there's discussions about whether we might loosen some of the restrictions around the variables in the headers of for loops. So I'm not going to predict how that discussion goes, but I think the positive thing I would say is that there is a discussion, discussion going on, and we'll see where we get to on that.
So I have to say, so effectively final is a simple. I mean, it's not like a beginner. It's simple for beginner. But if you're an experienced Java developer and somebody explains to you what effectively final mean, the variable could be final in the same scope and everything will still compile. That makes a lot of sense. But I still run into issues where I have a variable and then I do some assignment, and then comes the stream pipeline that references the variable, and the stream pipeline is like, oh no, you can't do this. And so that's also a situation where I'm not sure that's different from the for loop. The for loop, I think, is clearer where the scope is.
Yes, you can see the scope boundaries more clearly. But I think it's an example of how we can adjust, we can make changes. So we just need to, on that particular one, and read the latest discussions on it. On that particular one, I think we'll hammer through that, and then we'll come to a decision.
And one more thing I'm curious about that's currently going on, and that was something that also popped up to my extreme surprise in Brian's talk about Project Valhalla that he gave at JVMLS. That's already online on our YouTube channel. He will give another Valhalla talk, I think today or tomorrow.
Tomorrow, I think.
Tomorrow here at Devoxx Belgium, that will also show up, and as I said before, on both the Devoxx Belgium and Devoxx YouTube channel and ours. He talks about Valhalla and all that null restriction, and suddenly, seemingly out of nowhere, pops open. Oh, by the way, we want to reorder statements in a constructor, and that's really helpful here.
Yeah, so Project Amber to the rescue.
Yeah, is that part of your talk as well?
I will mention it as one of the things that we're also doing in Amber. It's a fascinating JEP, so there's a lot to it, but I'll try and be very brief. So really, what we're trying to do is reimagine the role of constructors in object initialization. So that's the grand sales pitch.
Okay.
So if you think about the way we've pitched object initialization, in the past, we've always said, for safety reasons, everything's top down. So you call a constructor in your class, everyone, if you don't say super, one's inserted, and it's inserted right at the front. If you say super, it also has to be at the front. Yeah. So what that does, and it's very beautiful, straightforward design, is that it ensures that everything is initialized top down. Yeah. So whatever your class is, you go up to object, it runs his constructor, then goes down, and then comes back to you. That's perfect, but there are an annoying number of cases where you'd really like to just do something that's perfectly reasonable before the super is called, like check some of the parameters to your constructor.
I think maybe it's important to explain why that is the case, though. I mean, like, why is the top-down? Why was that chosen in the past? It's not just for...
No, it's chosen because, just think logically, how could you... The idea is, I am not ready to do anything until my superclass has finished doing their thing, right? Because I might depend on it. Yeah. So I don't want to start constructing my parts of my class because I've inherited stuff from my superclasses, so they need to have finished setting all of that up before I can do my business. Yeah. But I might want to do something innocuous, like, hey, can I make sure the arguments are positive before you start calling? Yeah. Or can I, some other constraints? And well, you could do that, but in a very hacky way, and you were restricted. So what we're now moving to, the reimagining part of this, is basically saying, well, if you look at a constructor body, the new way to look at it is, let's imagine you've got a super call in there explicitly. There's the bit before it, call it the prologue. The bit after it, call it the epilogue. Great words. And the idea now is when you call the constructor for your class, your prologue runs first. Then your superclass's prologue runs first, and then their superclass, and they go all the way up to the object, and then all the epilogues start running. So instead of going top down, now we go up and then down. And now obviously you can't do everything in that prologue, right? So you can't mention fields from your superclasses and so on, and you can't rely on any part of the object that's being constructed. You can do some straightforward stuff, you can do some validation checks and so on. And this is actually, I think, leads to some very beautiful constructor bodies, so we're excited about that. And the interesting thing is that it actually, there's an old puzzler from years ago where you have your superclass has a method that it calls, but you've overridden it, and it's easy to set up a situation where you can end up observing your object in its pre-initialized state, because deep down the VM will actually, it sets up objects with null fields and all zeroed out. And you would have thought in the language there was no way for you to see that with that top-down thing. But it turns out there's a little puzzler where you can. Okay. And the cool thing is with these, this more flexible notion of a constructor body, you can actually now code defensively against that. So nobody can ever see that. And that was the feature the Valhalla guys needed. Because they're worrying a lot about strict initialization of their fields because they want everything to be a value and they don't want people to start interfering in the construction process. So by enhancing this in the language, the VM actually already had the ability to do this.
Yeah,
but you couldn't,
it's a language limitation.
it was a language limitation. But now we've got a way to kind of nicely encapsulate this feature. So, so it's very exciting.
Yeah, and also what's also exciting about this feature is a totally different perspective on it is that it's by Archie Kops, right? It's not a he came up with this idea.
So
he's not working for Oracle. That's why this is.
That's right. Archie is a great developer outside of Oracle. He's been involved in the Java compiler for a long time. He's just an outside committer, fixing bugs, doing a great job.
Yeah.
And then because that's a relationship that he's kind of engendered with the other compiler developers inside Oracle and people like me and others. He sort of came to us and said, you know, I've spotted this thing inside the compiler. It's really weird. And if we rejigged it, we could actually improve the language. And in the end, he produced a draft for the draft JEP, which myself and others worked on.
Yeah.
And so we've had this great collaboration. He's the owner of the JEP, so it's a JEP owned by somebody outside Oracle, but in collaboration with me and the other compiler team, he's actually got a feature that he's changing the language. It's hopefully previewing another version. We'll preview in 24. Fingers crossed, I think we'll finalize in 25 unless something
you're looking that far into the future.
We're way beyond that actually. But you know, so he will be a person who's like really changed the language forever. Right? Outside Oracle. So it's very cool.
There could be a first for the language, but it's not like there have not been other outside contributors that also wrote like even jabs, like I think of Roman Kenke, for example, about Lilliput, even a project lead. But it's really nice to see that if you are outside of Oracle, but a member of OpenJDK, and you have the expertise and the time that it takes to do these contributions, because that's the thing, right? I always dreamed of writing a JEP, but that's extremely unrealistic because of the expertise that I would need and also the time I would need to follow through on this. It's just a full-time job. And most people who use Java already have a full-time job. And so that's also why I recommend for those, if they want to contribute, it's just, it's like, I think on every stream, just try things out. Let's just give feedback and try things out. That's like the best first step. And even if you want to eventually get there where Archie is or where Roman is and contribute to JEP, that's still the best first step, right? To get in touch with the team, to get to know the people, to get to know the technology, to establish trust and expertise through work on the mailing list, on maybe then small bugs eventually, and then at the end of that long history lies.
I think it's, you know, it's common in open source projects, right? It's a community and it's about relationships, right? So you can't expect to just be a random person come in and say, here's how to, you know, here's my great idea for completely changing everything. That's going to be a hard sell, right? So, but if you can build relationships with people, then there's nothing to stop you. But it's a process, right? So you start and then you start making bug fixes and then people start noticing you and then and you get a much better understanding. So I think it's important not to underestimate, you know, the amount of work that's involved, right? Just making, you know, Java C, for example, the code that I look at the most, you know, it's a wonderful, beautiful piece of code, but it's huge, right? And it's complicated and it's not straightforward. So just wading in saying, oh, I've got to make a huge change, it's like, you've got to understand what that means, right? That's a lot of work. And, you know, it shakes up lots of things. There's lots of dependencies, lots of scaffolding, lots of testing and so on. So, you know, start small and then things can grow.
I think Brian,
and then, you know, a JEP results at the end.
I think Brian had a great section in his keynote today where he explained why things taking so long. And it's basically, well, it takes so long because it's a lot of work and there's a lot of work that's not actually visible. And that's also the same to me, right? Like I see something like flexible constructor bodies or string templates or like some features I feel like this looks like I could have implemented it, right? But I know that's wrong, but it's still like a first reaction because it seems when it's done, it seems so simple. Usually, not always, but still, but the time to get there and everything else needed to be done, and also what needed to be done under the hood for this hopefully simple-ish thing at the surface to be able to exist.
I think so. You know, I mean, it's a common analogy, but if, you know, you think of the swan gliding along the water, but underneath paddling like crazy, but from above, it's just very graceful.
I've never thought about that.
Gentle,
Okay.
right? So, and I think that's, it's, a lot of code is like that, right? So it's, we're gliding along, we're making progress, but there's actually phenomenal amounts of work. And, pay tribute to all my amazing colleagues in the compiler team and so on who do that work.
Okay, let's see whether we got any last minute questions. Super short answer. Could instance of statement be implemented to allow destructuring without using switch? It already does that, right?
No, I think they mean instance of statement rather than expression. Is that what they mean?
It's just could instance of statement. Yes. Could instance of statement. Now we have instance of expression. You got this better than I. Did you read this? Be implemented to allow destructuring without using switch? Short answer.
Yes. Fingers crossed. So it's in the pipeline. I mentioned it in my pipeline bit of my talk.
Okay, good.
We're working on it.
Good. So watch Gavin's talk when it's live online, and thank you very much for being here for your work on Java, but also for making the time to talk to us about it.
Yeah, it's great fun. Thank you.
Yeah, and I'll see everybody tomorrow at 10 a.m. for Victor Klang, I think, to talk about what we call Klang marshalling. See you tomorrow.